I have opened the hand grip dataset and we're going to look at testing one mean, and this might be something that you do if you want to see if you're getting similar results to something that's published. So let's say that someone else had published a paper saying that the average hand grip strength of people aged over 65 was 29.5 kilograms, and we want to test if our data matches that. Now, the first thing I would usually do with any data is do a graph, and you should be quite familiar with this by now. For a lot of these tests, we're interested in checking normality, and there is a formal normality test which we might get up to later. At the moment, we're just going to do a histogram and just do what's called eyeballing it. We're just going to take a look at it and see if it looks normal. So average hand grip strength is going down there. And if you see here on the left, we can display the normal curve. So let's tick that and apply. Okay. So we can see that it's not quite normal. One of the difficulties we've got here is that it seems to have been chopped off at 0, and this is because we can't have a negative strength. And so we've got what's called a truncated distribution. Now it's possible that apart from that, it's mostly normal. And it's also possible that this would look more normal if we had a bigger sample size. At the moment, because it's not completely normal, we would probably say we will interpret our results with caution. And later on, if we get up to it, we can do a formal test for how far away from normal this is, and we can have a look at that. So bearing that in mind, that we're going to interpret our results with caution, we're going to have a look at the one sample T test. So if we go up to Analyze and Compare Means, and we want a one sample test. So T is the name of the test statistic that we're using, and these names come from which distribution we compare our test statistic with. Now, as we're not doing the mathematics behind any of these tests, a lot of this will feel irrelevant. So you're just going to need to remember which test we do in which situation. So for comparing one mean, we'll be doing a one sample T test. If we click that, you can see that I've already put average hand strength in there. Options. We've been doing everything at the 95% level. You're welcome to try a different confidence level if you like. Missing values is how to treat your data if you've got missing data in there. I don't think we've got any missing data in this set, so that won't be relevant. And hopefully for your projects you won't have any missing data either. Now the test value is here. Now if you remember from the test from the textbook, we can only test something very specific because we have to be able, we as in the computer has to be able to calculate the probability of getting the data if that value is correct, and it can only calculate the maths on something very specific. It can't calculate something vague. So we can't calculate the probability on a vague statement. We have to give it a specific value, and in this case we've said that another paper has found that the mean hand grip strength is 29.5 kilograms, so we're going to test that. And that's it. What we have here is first a little description of the data that it's looking at, the number in the sample, the mean, standard deviation and standard error of the mean. And you can see that the mean is a long way from 29.5. It's very, very low. What we have down here are the details of the test. If you're interested in the mathematics behind this test, it's not too difficult. You're welcome to look that up. T is the test statistic, and this is the value that is calculated in order to then get a probability on it. The degrees of freedom is related to, DF is related to how we get our p-value and the distribution that we're comparing this value with, and the significance here is the p-value. So this is probably the most important thing that you're interested in, is the significance. So the null hypothesis for this test is that the mean is equal to 29.5. A p-value of 0.000 or almost 0 tells us that there is very, very little chance of having got this data if this hypothesis is true, and therefore this hypothesis is probably not true and the mean value is something else. It doesn't tell us what the actual mean value is. We would do a confidence interval around the mean to estimate the mean value. It just tells us that it doesn't seem to include 29.5. So on the scale of evidence against the null hypothesis, this is very strong evidence against the null hypothesis, and therefore we would go with the alternative hypothesis that the mean value is something different to 29.5. So the null hypothesis is always the very specific hypothesis that something is equal to something else, or that there is zero difference, or there is zero association, something very precise. And the alternative hypothesis is always the vague one, that there is a relationship, we don't know what it is, but there's something going on, the mean is something different, there's something else. And so we have very strong evidence against the null hypothesis, and that would support the alternative. So we would say in this case that there's very strong evidence that the mean is not 29.5, and we can see here that it's much, much lower. So that's a one sample test where we're testing one mean, and then in the next video we'll have a look at doing a two sample test where we're looking at two means in the one data set.